Welcome to the lecture. Today we are going to see the topic mesh analysis. Mesh analysis is nothing but we are going to determine the current in each loop. First of all, we have to define what is mesh. A mesh is defined as loop which does not contain any other loops within it. This mesh analysis is applicable only for planar network. So, what is planar network? A network is said to be planar if it can be drawn on a plane surface without crossovers. It's called planar network. Now we are going to determine current in different branches. We can use the mesh analysis. Now before going to apply the mesh analysis, we have to follow the procedure. Step 1. Identify number of meshes in the given circuit. Next step. Assume the current in clockwise direction. Step 3. Apply KVL and Ohm's law to write the mesh equations in terms of unknown currents. Step 4. Check whether the number of equations with number of unknowns are same. Step 4. Determine the current in each loop by solving network equations using Cramer's rule. For solving mesh analysis, we can take one small example. Find the current through 5 ohm resistor in the given circuit. Now, step 1. Here we have to identify the number of meshes. In the given circuit, here we are having 3 meshes. So, next step, we have to assume the current direction. Assume the current direction in a clockwise. So let I1 be the current in loop 1, I2 be the current in loop 2, I3 be the current in loop 3. So for each mesh we have to apply KVL. So apply KVL to loop 1. So how we can define KVL? The algebraic sum of all the voltages in a closed path is equal to 0, or the algebraic sum of voltage rise is equal to algebraic sum of voltage drop in a closed path. Now for each loop we have to apply the KVL. Now in this loop 1, first we have to identify whether the voltage source are connected in a loop. Yes, in this loop 1, the 10 volt source is connected. So we have to check whether it is voltage rise or voltage drop. So now the 10 volt source and the assumed current directions are in same direction, so that the 10 volt source is a voltage rise. Now we have to write the KVL equation for loop 1. So the voltage rise, that is 10 equal to 1 into I1 plus 3 into I1 minus I2 plus 6 into I1 minus I3. Now, the 3 ohm resistor which is connected in common for loop 1 and loop 2. So that here we are writing 3 into I1 minus I2. Why we are writing I1 minus I2 means here we are taking loop 1 as a major, so that we are writing I1 minus I2. Similarly, for 6 ohm resistor, it is connected common between loop 1 and loop 3. So that we are writing 6 into I1 minus I3. Now we have to simplify these equations by combining all the coefficients. Now here you are having 1 I1, here you are having 3 I1, here you are having 6 I1. Combine all the thing, we can write 10 I1 minus 3 I2 minus 6 I3. So now we have to write the simultaneous equations in terms of all the unknown variables equal to a constant. So we are rewriting this equation: 10 I1 minus 3 I2 minus 6 I3 equal to 10. Take this as equation number 1. Similarly, we can write the KVL equation for loop 2. Apply KVL to loop 2. Now, we have to we have to see that whether the voltage source are available in loop 2. Yes, there is one voltage source are available in loop 2. Now we have to check whether it is voltage rise or voltage drop. Now, here the 5 volt source is voltage drop. Why? Because the current assumed direction is opposite to your given voltage source. So that we have to write minus 5 equal to 3 into I2 minus I1 plus 2 I2 plus 5 I2. Similarly, like previous step, here also you have to simplify the equation by combining all the coefficients. So, minus 3 I1 plus 5 plus 3 plus 2 plus 5 is become 10 I2. So, we can rewrite this equation minus 3 I1 plus 10 I2 equal to minus 5. So, take this as equation number 2. Similarly, apply KVL to loop 3. Now we have to find whether how many number of voltage sources are connected in loop 3. Yes, here the two voltage sources are connected. One is voltage 5 volt source, another one is 20 volt source. We have to check both are voltage rise or voltage drop. Now both the voltage source are in same direction, so that both the voltage source are voltage rise. So we have to add. So 5 plus 20 equal to 6 into I3 minus I1 plus 4 I3. Now simplify this equation, minus 6 I1 plus 10 I3. So again rewrite this equation, it becomes minus 6 I1 plus 10 I3 equal to 25. Take this as equation number 3. Now, now solve solve the equation 1, 2, 3 using Cramer's rule method. Either you can use Cramer's rule or you can solve the equation using calculator. If we solve this equation, we get I1 is equal to 4.27 amps. I2 is equal to 0.7818 amps. I3 equal to 5.06 amps. So now, if you solve these three simultaneous equation, either using calculator or you can use the Cramer's rule. If we solve, we will get the values for I1 is equal to 4.27 amps, I2 equal to 0.7818 amps, I3 equal to 5.06 amps. Still, the problem is not completed. Here they are asking find the current through 5 ohm resistor, where the 5 ohm resistor is connected, which is connected at loop 2. So at last you have to write current through 5 ohm resistor. So I5 ohm is equal to I2. So what is the current I2? I2 is 0.7818. Directly we can write I5O is equal to 0.7818 amps. So this is all about mesh analysis.